Hello, this is Professor Keene. In my last lecture on Pascal, we talked about why it is that some bodies float and some bodies sink using Archimedes' principle. And so I just want to pick up on the discussion and say one more thing about that. This is on page 191 in A Student's Guide to the Great Physics Texts, Volume 2. And here, what Pascal does is he talks about when you balance two objects in one medium, how they may not be balanced in another medium. So what do I mean by that? So let's ask the following question. What happens if you balance, this will be a short lecture by the way, this is just one more point I want to make. So if you balance a gold and a platinum mass in air, then you submerge the balance underwater. So I'll draw a picture. So if we have, let me move this over to here so it's out of my way. Maybe I'll move this over here too. In fact, I don't even need that. Let's get rid of that. So let's draw some water. Or let's draw water. Let's not draw water yet. Let's suppose we have this balance. Okay, this is just a regular laboratory balance. And we hang from one side a block of gold, and we hang from the other side a block of platinum. Notice the block of platinum is smaller than the block of gold. Why is that? Because platinum has a higher density than gold. This is going to be critical, but the important point is the weight of the gold block is exactly equal to the weight of the platinum block. That's why they are balanced. Now, what happens if you were to take this whole situation and you were to put it underwater? So we take this exact, here, let me try to do this. I'll just redraw it. If we take this entire situation, I don't want to take the time to try to cut and paste. That'll take me a minute to figure that out. So I'll just redraw it. If you take this entire thing, you've got the gold block on this side and the platinum block on this side, and you take the whole thing and you submerge it, what's going to happen? Well, what do you think? Now, this side right here is going to move upward, and this side right here is going to move downward. Why do you think that is? Well, because the volume of the gold block is greater than the volume of the platinum block, right? That is because the density of the platinum is equal to about 21 grams per cubic centimeter, and the density of gold is about 19 grams per cubic centimeter. Since the platinum is more dense, it requires less platinum or less volume of platinum to balance gold. Now, why is that relevant? Well, when you put it underwater, remember that the buoyant force that acts on this is equal to the weight of the water displaced. And the buoyant force acting on this is equal to the weight of the water that displaces. Which one displaces more water? Well, the gold displaces more water because it has a larger volume. Hence, the buoyant force acting on the gold is going to be greater than the buoyant force acting on the platinum. So although the weights remain the same, the buoyant force acting on the gold is going to be bigger, and hence it will no longer be balanced. And this is precisely what Pascal mentions in section 15.2.1.7, where he mentions, for the same reason, two bodies, one copper, the other lead, of equal weight and consequently different volume, since the same weight requires more copper, will be found to balance each other on the scales, but if the scales are put in water, the equilibrium is lost, for each body being counterbalanced by a volume of water equal to its own, and the volume of the copper being greater than that of the lead. The copper has a greater counterpoise, and accordingly the weight of the lead is the master, that is, the lead falls and the copper rises. He goes on to say something interesting. He says that if you balance copper and lead, or like our example, gold and platinum, in air, and then the moisture or the humidity of the air changes, then they may not be balanced because moist air is going to exert a bigger buoyant force on the gold than on the platinum. So I'll stop there. Until next time.